Alright, welcome back. So in this session we're gonna do a coding session on a time series, and this is called the temperature forecasting problem. You can find that exercise in Francois Chollet's book. The only difference is that I introduced pandas here, because I think pandas is easier to pre-process the data. So as part of this coding session, we're also going to touch upon three items that are important. One is recurrent dropout. We've seen dropout in the past, but what does it mean in a recurrent neural network? How to stack recurrent neural networks. For example, Google Translate is just a stack of multiple of these recurrent neural networks. And then we're going to take a look at bidirectional recurrent layers and how this can help us as well. The data set is the weather time series from the Max Planck Institute in Germany. And basically what you have is, since 2009, or between 2009 and 2016, every 10 minutes, 14 weather features were recorded. So 14 weather features like temperature, pressure, and so on. And this was recorded every 10 minutes. It was actually started in 2003, but the data set we look at is 2009, 2016. So the number of recordings or data points we have is about 420,551. So the goal is to predict the temperature forward 24 hours based on information in the past 5 days. So we have 5 days look back, as we call it. We have steps 6. Remember, we have recordings every 10 minutes, but we're gonna sample only every hour. So that's why we will take 6 of these steps. And then the delay is the forecast horizon. Now we want to forecast 24 hours in advance. Alright, let me make a little bit of a drawing related to the coding exercise. The coding exercise is not very difficult, but the definition of the generator is quite complex. So I will try to highlight here a little bit on what is happening. So basically we have an index going from 0 to 425.51. These are actually all the recordings of every 10 minutes. What we're going to do is take a training set between indices 0 and 2000. 200,000, sorry. And remember, 200,000 is not included if we work with NumPy arrays. And then we go from 200,001 to 300,000 for the validation set. And then everything else is going to be test set. Alright. Now we know that there is a look back, and we know that there is a delay. So the first useful point is going to be this one here, because we need to be able to look back 720 minutes, right? So this point here is going to be the index 790, in total 720 readings. And also on this side we will need to subtract our delay of 144. So the other useful index is going to be 199,855. Alright? So anything between these two dotted or striped red lines is going to be the relevant training data, and we're going to take a batch size of 128. You will see in the exercise that we will define, enumerate in terms of variable j. Well, j is your observation, and then I have to subtract the loopback from j, and I have to add 144, which is the delay in the future. Now I can take any j on this line. And now you're gonna say, but why are you gonna shuffle? I thought that the sequence was important. Well, it still is, but as long as you take these blocks, you can take any j, because your sample is gonna include the loopback and it's gonna include the forecast of your temperature. So it's a better way to shuffle here. Here and here the shuffling is not needed, because we will have a model, and that model will be able to predict anything. Yeah? Alright, so how does a batch look like? Well, you have this index here that is a function of time, and here you have your batches. Yeah? And you also have your 14 weather features. So one batch, as I showed here, could be from j to j plus 4608. Basically, this is a batch size of 128, but these are 128 hours. So if we convert that to minutes, your next j is going to be j plus 4608. And so here you have 768 samples in your batch. Intuitively, you have your RNN here, and you have your input, which is your batch that you're going to inject here. Now this will be 4,000, no, not 4,000, this will be 768 parallel lines to absorb your input. And then we're going to take a look at j plus 144 minutes, and this will then be your Y predict. Alright, with this batch 1 being your input. So that is the exercise.